Hi, I'm Kathy Manley. This video covers Lesson 3, Programming with Angry Birds from Course C. There are 3 lessons that we've asked you to do with your students this fall. Those include Lesson 1, Putting a Stop to Online Meanness, Lesson 3, Programming with Angry Birds that we're covering today, and Lesson 6, Creating Art with Code. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in the lesson, to model pedagogical strategies for implementing the lesson, and to review computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies addressed in the lesson. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence and loops as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. We will focus on decomposition, pattern recognition, algorithm, and debugging as shown in bold. Students will use additional critical thinking skills such as compare and contrast, cause and effect, predict, problem solving, plan, and observe. In this video, I'll walk through this lesson and point out opportunities to use the following pedagogical strategies to support student learning. We will use student-centered learning, where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach, where students predict, run, investigate, modify, and make a program. Lastly, we will focus on the process of problem solving. You will begin the main portion of this lesson by showing the video Intro to Code. Take some time for direct instruction throughout the video and lesson to reinforce the goals of the activities and to develop a common vocabulary. Have students pull up Lesson 3 and go to Puzzle 2. Puzzles 2 through 7 help students learn and practice using the blocks. Give students time to play, think, and code when they have these sets of puzzles. If students have trouble, encourage them to read the instructions aloud. Also encourage students to ask each other for help before asking you. Puzzle 2 helps students practice using the blocks. Show students how to click on the speaker icon in the upper right-hand corner to have the instructions read aloud to them if needed. In this puzzle, students will drag the move forward blocks to connect them to the when run block. Have the students observe the code. Discuss how the steps they see are an algorithm. Have students make a prediction about what will happen when they click run. Talk about cause and effect. When I press run, a cause, the Angry Bird performs a behavior of moving forward twice, the effect. By attaching the blocks to when run, students have created a program telling the computer what behavior or task to perform. In Puzzle 3, students will do the same thing they did in Puzzle 2, but they will add one more move forward block. Puzzle 4 introduces students to debugging. Have students observe the code. The program will follow the sequence or order of steps. Discuss the PRIM approach: predict, run, investigate, modify, and make. If they push run, what do they predict will happen? They run the program and notice that the Angry Bird crashes. So they're going to investigate, why did the bird crash? There is a bug in the program. So they're going to debug the program or modify it by removing the extra move forward block, then running the program again. In Puzzle 5, this focuses on problem solving using decomposition. What is the problem to be solved? Your students should say that the problem is to get the bird to the pig. How does the bird get to the pig? Decompose the path into steps. The bird needs to move forward and turn. Move forward how many steps? Turn left or right? What is the last step? Does the sequence of the steps matter? Once they have an algorithm, the steps to take, they will turn their steps into a program for the computer to run. In this case, they will move forward, turn right, move forward, turn left, and then move forward again. If they left out a move forward in there. If they run the program and it doesn't work, then we can go back to talking about debugging. Did they leave out a step? Did they turn in a wrong direction? Then they move on to Puzzle 6, which is similar to Puzzle 5. Well, they're going to use that same decomposition to figure out what steps they need. Puzzle 7 introduces the repeat option. Students will follow the same steps they did in 5 and 6. Once students have the code as I've shown here, Ask students where they see a repeating pattern in the steps. They should notice that the move forward is used 3 times in a row. They can use the repeat button to create a loop and tell the program to repeat the move forward 3 steps before moving to the next step. So we're going to take this repeat and connect it up here. And we only need one of these move forwards because we're going to tell it to repeat move forward 3 times. So all we've done is replace that with a loop. So encourage students to try using that loop. And then they move on to puzzle 8. They'll have a challenge. And in this challenge, they're practicing debugging. In puzzle 9, they're going to practice decomposition and looping again. In puzzle 10, this is a prediction. And if you were showing this, once you have done it, you won't be able to undo it. So you can just slide this up and cover your prediction. Ask the students to use the PRIM approach again. If they push run, what do they predict will happen? Have them mark their prediction and then check it by running the program. And then they can also investigate by using this step function. And what it will do is take them through each step of the program, 1 step at a time, so that they can see what's going to happen. And that will help them to really go through and debug their programs. Puzzle 11 challenges students. You can have them do things like try to find the shortest route, use the fewest blocks, use the most blocks. And if students finish early, encourage them to try out some of the bonus levels. Once everybody's done, wrap up by asking students what they learned. Remember, play is part of learning, so encourage them to share fun aspects as well as the computational thinking concepts and powerful ideas that they remember. Review problem solving in the PRIM approach to encourage them not to just jump in and start dragging blocks in a trial and error manner. Let's take a moment to debrief. We covered several computational thinking concepts and powerful ideas that align with this lesson. Sequence, did the order of the steps matter? The order of the steps mattered because they had obstacles that needed to be avoided. Loops, the repeat button allows students to create loops to repeat a pattern of steps. Decomposition, when talking with students about breaking the problem into smaller steps, you help them decompose the larger task. Pattern recognition, in order to use the repeat function, students needed to identify a repeating pattern. Students should be more familiar with the term algorithm as a list of steps. And debugging is the process of finding bugs or parts of the program not working properly and fixing the problems. We applied critical thinking skills by having students compare and contrast the blocks, and we should have them compare that with the JavaScript code that they can see. Observe blocks, make predictions, then observing cause and effect when clicking run, solve problems, and make a plan. We also employed a variety of pedagogical strategies by encouraging students to play, think, and code while providing direct instruction for key elements. Students also focused on understanding the problems, devising solutions, and using the PRIM approach to investigate and make their programs. When you are working with students, it can be helpful to reinforce this vocabulary, especially in other classroom activities, to reinforce the skills that they're learning. Thank you for watching this video.